Hi, this is my final project. I have taken the topic for the final project is like analysis of 2010 census population in the United States of America, and the libraries I have imported is like Pandas, NumPy, Matplotlib, and Seaborn. Pandas and NumPy are for the dataset, reading the dataset and some changes that I can made for the dataset, and the Matplotlib and Seaborn are for the visualization of the dataset. And coming to the dataset, I have 319 rows and 7 columns, and the 7 columns are zip code, total population, median age, total males, total females, total households, and average household size. So all the 7 columns doesn't have any null values. Those are all the 319 rows are non-null, and those are of int and float data types. Nothing is like string or character. So the zip code is like a particular, it indicates a particular area. Total population, it represents the number of individuals living in that particular area. Median is like it divides the population into two types. One is like older and one is younger than the particular age. Total males and total females. Total households is like a group of people living together or sharing a common living arrangement. It indicates a family or a group of people living together. Average household is like average number of individuals living in each household, and these are the count, mean, median, and standard deviation of my particular data set. So checking the duplicate values here, and no duplicates were found. If in case any duplicates, those are filled with the mean value of the my data set. And coming to the visualizations, firstly I have visualized the histogram plot for total population. The height of the, it's like the x-axis consists of total population and the frequency. So the height of the bar indicates the total number of zip codes in that particular range. So it's like 30,000 population. The most of the zip codes falls in the 30,000 population, and for the median age, the most of the zip code, like in the most of the zip codes, the median age is like it near 40, in between 40, and most of the males were. And coming to the scatter plot, for the scatter plot I have taken total households versus average household size. So in which each particular point represents a zip code. So on the x-axis I have taken total households, and the y-axis average households. These are the total number of zip codes that have fallen in between two columns. And coming to this graph, it indicates between population density and total population. These are the zip codes on the x-axis. It gives the population density versus zip code. So this larger drop indicates the more density, like a more population, and the smaller dot indicates the less population. And coming to the correlation heat map, the most correlation is in between total females and the zip code. And the maximum this is the code for identifying the zip code for the maximum population and what is the maximum total population. So the maximum population is in the zip code 90650. For that particular zip code, the total population is like 10, it's like 1,514, like 1,05,549, and it's for minimum population. So in this particular zip code there is 0 for the total population, so it's a minimum one. And coming to this, the most in the more population zip code 90650, there are mostly more females in the particular zip code, and this is the bar chart for the households of the particular zip codes. And compared to the maximum population, comparison of households in the zip codes, so maximum population has more total households. That's a common thing. So there are few zip codes, there are only few zip codes that are less than a lesser population.